Contour integration type 2. Integrals of the form integral minus infinity to plus infinity f of x dx, where f of x is equal to p of x by q of x, and the degree of p of x is lesser than the degree of q of x by at least 2. To evaluate this type of integrals, consider an upper of circle C with radius r and center at the origin such that C is gamma plus minus r to plus r. That means a diagram like this, minus r to plus r, the C entire of circle C is minus r to plus r and gamma, sum of these two. So therefore the interval over C f of z dz equal to minus r to plus r f of x dx plus interval over gamma f of z dz. So as r tends to infinity by Cauchy lemma, interval over gamma f of z dz tends to 0. Therefore this equation becomes integral minus infinity to plus infinity. As r tends to infinity, this becomes 0. So only interval over C f of z dz. By Cauchy residues theorem, this integral is 2 pi I into sum of the residues of f of z. So this is a procedure for evaluating the integral contour integration of type 2. So now the first problem, this is the first problem. Evaluate integral minus infinity to plus infinity x square dx by x square plus 9 into x square plus 4 using contour integration. So now this is contour integral of type 2 because the integral having the limit minus infinity to plus infinity and p of x by q of x form. So in this type we have to consider an upper of circle C like this. Here C is minus r to plus r plus gamma. So now the interval over C f of z dz is equal to minus r to plus r f of x dx plus interval over gamma f of z dz. As r tends to infinity by Cauchy lemma, interval over gamma f of z dz tends to 0. That means it is 0 means as this integral becomes like this. And now integral over minus infinity to plus infinity f of x. What is f of x? Given integral function f x square by x square plus 9 into x square plus 4 into dx is equal to interval over C f of z. What is f of z in terms of z? Z square by z square plus 9 into z square plus 4 into dz. Now this is by integral over C f of z dz by Cauchy residues theorem. By Cauchy residues theorem, this is become 2 pi I into sum of the residues of f of z. So take equation number 1. So to complete this problem, we have to find out the residues of f of z. So what is f of z? F of z is z square by z square plus 9 into z square plus 4. So now we have to find out the residue of f of z. So to find the residue, first we have to find out the poles. Poles mean to find the poles, put the denominator equal to 0. So what is the denominator here? Denominator equal to 0. Denominator is z square plus 9 into z square plus 4 equal to 0. So now z square plus 9 equal to 0 and now z square plus 4 equal to 0. So from this z square, that means z equal to plus or minus 3i and z equal to plus or minus 2i. So now there are 4 poles, plus or minus 3i and plus or minus 2i. And also these poles are simple poles. Now we have to verify which one lies inside. You see, this is upper of circle. So this is a real axis, this is the imaginary axis. Now as r tends to infinity, now all the imaginary values are lies inside. All the positive imaginary values are lies inside. But all the negative imaginary values are lies outside of C. So now here plus 3i is the positive values, positive imaginary side, and plus 2i also positive side. So these two are lies inside C, but the negative value 3 minus 3i and minus 2i are outside C. So now here the poles, now the poles z equal to, now the pole z equal to 3i comma 2i are simple poles and lies inside C, inside the circle C. But the another two poles minus 3i and minus 2i are also simple poles, but lies outside C, outside C. So only two poles are lies inside C, 3i and 2i. So now we are going to calculate the residue for these two poles. So now the residue formula for the simple pole. So residue of f of z at z equal to a, where a is a simple pole. So limit z tends to a, z minus a, f of z. So this is the formula for residue for z equal to a simple pole. So now residue of f of z at z equal to 3i, where 3i is a simple pole. So now limit z tends to 3i, z minus 3i into f of z. What is f of z? Z square by z square plus 9 into z square plus 4. So now limit z tends to 3i, z minus 3i into z square by this z square plus 9 can be written as z plus 3i into z minus 3i, and now z square plus 4. So z minus 3i cancel. Substitute z equal to 3i here. 3 square 9, I square minus, so minus 9 by, substitute 3i here, 3i plus 3i 6i, and now substitute here minus 9, so minus 9 plus 4, so cancel, 2 3s are 3 3s are, so now minus 3 by, this is minus 5, so minus 10i, this is I. So now finally this is 3 by 10i. So 3 by 10i is the residue for z equal to 3i. So we found one residue. So now next we are going to find another residue for z equal to 2i. So now next one, residue of f of z at z equal to 2i. So limit z tends to 2i, z minus 2i into f of z, into f of z. So now limit z tends to 2i, z minus 2i into f of z is z square by z square plus 9 into z square plus 4. So now to cancel z minus 2i, we are going to split this z square plus 4. So now limit z tends to 2i, z minus 2i into z square by z square plus 9 into z plus 2i into z minus 2i. So cancel z minus 2i. So now substitute 2i here, minus 4 by, substitute here 2i, minus 4 plus 9 into here 2i plus 2i, 4i. So cancel 4. So now minus 1. So minus 1 by, this is 5i. So this is another residue for z equal to 2i. So now we found two residues. So substituting in 1. So what is 1? 1 implies that interval over minus infinity to plus infinity, x square dx by x square plus 9 into x square plus 4 is equal to 2 pi I into sum of the residues. 2 pi I into sum of the residues. First residue is 3 by 10i and another residue is minus 1 by 5i. So now take LCM. LCM is 10i. So now 2 pi I into This is 10i. So 3 minus 2. So 3 minus 2 is 1. So now I cancel 2 5. So answer is pi by 5. So this is the answer of the given problem. For the continuous support, subscribe this video. Visit us www.adariganesh.com. Purchase our textbook for the easiest method of solving problems. All the best.